In this question we're told when 30 grams of ethanoic acid and 23 grams of ethanol were placed in a conical flask and a few drops of concentrated sulfuric acid were added, an equilibrium was set up with the formation of ethyl ethanoate and water. The equilibrium is represented by the following equation. When the equilibrium mixture was analysed, it was found to contain 10 grams of ethanoic acid. Write the equilibrium constant expression, Kc, for this reaction. So for part 1, to write the equilibrium constant for the reaction, I need to write the concentration of the products over the concentration of the reactants. So my products are what appear on the right hand side of my equation. So I have CH3, COO, C2H5, that's one of my products, and my next product is water. Make sure those brackets are square brackets and not round brackets because you'll lose the marks. It will be completely wrong if you use round brackets. Square brackets denote concentration in moles per litre, and that's what we're talking about here. All of these are concentrations. So we have our products on top. We need to put the reactants on the bottom, so that's what appears on the left hand side of the equation. And because I don't have any coefficients to put in, I don't need to add in any powers. That is part 1 finished. Done. For part 2, I need to calculate the value of the equilibrium constant Kc. Now to do that, I need to know what the concentration of all 4 chemicals in that equation are at equilibrium. And I don't know that yet. So I'm going to use this ICE table here in the bottom left to find out. But what I can put in the ICE table are concentrations in moles per litre. As we can see from our question, I don't actually have concentrations in moles per litre. I have gram amounts. So first I'm going to change them into moles. So if I have 30 grams of ethanoic acid, so I have 30 grams of ethanoic acid, okay, and that's initially, okay, so that's placed into the conical flask, so that's an initial value. I'm just going to put an I beside it for initial. Now to turn grams into moles, I need to divide by the molecular mass of ethanoic acid. So if I add up to find the molecular mass of ethanoic acid, so we have a 12, we have 3 ones, we have a 12, a 16, a 16 and a 1, so it's 60. So the molecular mass is 60 for ethanoic acid, and if I divide 30 by 60, I get 0.5 moles. So that's that converted into moles. Then I have 23 grams of ethanol, so I have 23 grams of ethanol, that's C2H5OH. That was also placed in the conical flasks. That's also an initial value. And to turn that into moles, I need to divide by the molecular mass. And when you add up the atomic masses for those atoms in ethanol, you'll see that it's 46. Just double check that. Yeah, 46. So if I divide 23 by 46, I get 0.5 as well. That's 0.5 moles. Finally, I need to turn this 10 grams of ethanoic acid into moles. So I have 10 grams of ethanoic acid. And we're told in that sentence that when the equilibrium mixture was analysed, so it's at equilibrium, then it had 10 grams of ethanoic acid. So this 10 grams of ethanoic acid isn't initially, it's at equilibrium, E for equilibrium. So to turn that into moles, divide by the molecular mass again, and we know from above that it's 60. So if we divide 10 by 60, it's 0.1667 moles. So we have all of those values now as mole values. And from the question, we don't actually know the size of the container. So, for example, the 30 grams of ethanoic acid, I know I have 0.5 moles. But but I don't know whether it's moles per litre, moles per 10 litres, moles per half a litre. I just know it's moles. Because we don't know the size of the container, we can assume it's 1 litre. So unless you're told otherwise, assume your container is 1 litre. So they are moles per litre values. Now I need to fill them into my ice table. And we call it an ice table because we have 3 different rows in it. I, C and E. I for initial concentrations, C for the change in concentrations, and E for the equilibrium concentrations. So for my 30 grams of ethanoic acid over here on the right hand side, that's 0.5 moles initially, because of the I, of ethanoic acid. So I'm going to put 0.5 in the initial row for my ethanoic acid. For my ethanol, in its initial row, I'm also going to put 0.5 moles from the second piece of information we were given. And then for the third piece of information that we were given, I know that at equilibrium, I have 0.1667 moles of ethanoic acid. So 0.1667 moles of ethanoic acid. Now what we need to do is, from the information we have, fill in the rest of the table. Now what I can say is, initially I had half a mole of ethanoic acid and half a mole of ethanol, which means I had none of my product and no water formed because the reaction hadn't started yet. This is initially, at the moment the reaction began. What I can also say is, I initially had half a mole of ethanoic acid and I finished with 0.1667 moles of ethanoic acid. So I can work out what that changed by subtracting. And it actually changed, it went down by 0.3333 moles. The concentration went down because it was used up. Now once we have a change value in there, I can fill in the change values for every other chemical because we know the ratio between each chemical. So in the chemical equation we know that we have 1 is to 1 is to 1 is to 1. Everything has a 1 in front of it. There are no other coefficients up there. So if I used 0.3333 moles of ethanoic acid, I must have used an equal number of moles of ethanol. So that's what got used up from the reactants. On the other side of the equation, because everything is still 1 is to 1, if I used up 0.3333 moles of each of my reactants, I must have produced 0.3333 moles of my ethyl ethanoate. I made that from 0. And likewise with the water, I'd have made 0.3333 moles of it. Okay? And now I can fill in my equilibrium concentration. So if we look at the column for ethanol, I began with 0.5 moles. I used up 0.3333 moles. So I'm left with 0.1667 moles. For my ethyl ethanoate, I started with nothing. I produced 0.3333 moles. So I have 0.3333 moles. Likewise with the water, started with nothing, produced 0.3333, so I now have that many moles. So I have all the numbers in my equilibrium row now. Because I have all of this from my equilibrium row, I can substitute that back into my equilibrium constant expression, and that will tell me what the value of the equilibrium expression is, or the equilibrium constant. I can find out what Kc is. So I'm going to write that expression again down here. So I have Kc equals CH3COOC2H5 in square brackets with my water all over my ethanoic acid concentration and my ethanol concentration. So I have equilibrium constants for all of those. Remember, we only sub in the values from this row, the equilibrium row, never from any other row. So to substitute into there, I need the concentration of my ethyl ethanoate, and that's 0.3333 0.3333. My water concentration is the same all over my ethanoic acid concentration and my ethanol concentration. So once we have all that, you can get your calculator out and you can type that in. And it works out to be 3.9976, so it's roughly equal to 4 is our equilibrium constant at that temperature.